Problem number 14, determine if the series, the sum of m from 1 to infinity minus 1 to the n times n to the fifth divided by n cubed plus 7 converges absolutely, converges conditionally, or diverges. Now I'm going to do something a little bit weird here in this video. I'm going to go down the wrong track for answering this question first, and then I'll explain what we should have done later. So there's a very big temptation here to think about the alternating series test. I mean, we see a minus 1 to the n. We can rewrite this as minus 1 to the n times n to the fifth divided by n cubed plus 7, where for purposes of the alternating series test, this is our b sub n. Okay, so let's bring out the alternating series test here to look at. Assume that Bn is a positive sequence that's decreasing and converging to 0, decreasing and the limit of Bn is equal to 0. Then the alternating series we get by multiplying Bn by minus 1 to n, or n minus 1, and summing that, converges. So the temptation right now is to keep looking here and say that the limit as n goes to infinity of b sub n, if this limit is 0, and we show that the Bn sequence is decreasing, then we can say, alternating series test, this converges. But when we go ahead to compute this limit, we get infinity. Okay, so the temptation here, something that lots of people wrote this kind of thing I saw earlier. So because we don't have 0, because we have infinity, by the alternating series test, since the limit as n goes to infinity of b sub n is equal to infinity, this series diverges. And so a lot of people gave me this kind of answer on a similar problem here. This is actually wrong. You're not allowed to do that. So the alternating series test is a series that can only be used to show that a series converges. There is no way to use the alternating series test to conclude that a series diverges. Either the alternating series test tells us a series converges, or it simply doesn't apply. So the alternating series test does not apply here, so you're not allowed to do this. So I said I'm doing this in a slightly weird way. I'm doing kind of like going down the wrong track first before I say what we should do. So all is not lost here. We realize that the limit of the individual terms about the minus 1 to the n is infinity here, and that tells us that the limit as n goes to infinity of minus 1 to the n times n to the fifth divided by n cubed plus 7, this does not exist. If n is even, those terms are going off to plus infinity. If n is is odd, the terms are going off to minus infinity. So we say here this limit does not exist. Don't write plus or minus infinity. We can only have one limit. If some of the terms are going off to plus infinity and some of the terms are going off to minus infinity, the overall limit doesn't exist. And this is enough for us to know that this series diverges by the nth term divergence test. So the nth term divergence test, it's a kind of complement to the alternating series test. We can only use it to show that some series diverge. We can't use the nth term divergence test to show that series converge. The alternating series test we can't use to show that series diverge. We can only use to show that series converge. So if you go down this path, it's completely reasonable to think alternating series test here. But if you get like infinity here, or anything that's not 0, you shouldn't be saying the series diverges. You should be thinking, you shouldn't be saying the alternating series test shows us that the series diverges. You should think about the nth term divergence test instead.